In this video, we're going to talk about how to model two variable equations. So the first example on the screen says a jar has a mixture of camels and humans. I know that sounds like a weird statement, but when I say I have a jar, I mean like a jar of wooden camels and wooden humans. Anyway, there are 21 animals in all. In Desmos, type an equation that models this situation. Use the graph to find the combination of animals that could be in the jar. So I'm going to say camels are x and humans are y. So our equation is x plus y, x plus y equals 21, right? The number of camels plus the number of humans has to be 21. And this graph shows us all the possibilities that make that statement true. Now, like this one here, 6.53, 14.47, that's obviously not a solution, right? There's not decimal camels and humans, right? But 0.21 is a possibility, and 5.16 is a possibility, and 15.6 is a possibility, right? So we have enough information to write this as an equation, but we don't have enough to know exactly what's in the jar. We need some more information. So how about this? What if I also tell you that there are 56 legs in the jar? That's enough information to write a second equation. If I know how many I know the number of camels is x, well, camels have 4 legs, so that would be 4x. Plus, I know humans have 2 legs times the number of humans. And I know that those numbers have to add up to 56. So notice we have a second equation here, and we end up with an intersection. That's the only possibility that would have 21 animals and 56 legs. And yes, in the jar, there are 7 camels and 14 humans. Let's do another example. A jar has a mixture of pumpkins and apples. I spent $31 to buy the pumpkins at $2 each and apples at 25 cents each. So let's do pumpkins as x and apples as y. So if I spent $2 per pumpkin plus 25 cents per apple, my total was $31. So there's a line that represents this situation. And it's a pretty far out. I have to zoom to get all the possibilities, because this statement could be that I bought 0 pumpkins and 124 apples. Or all the way down here, I could have bought 15.5 pumpkins and 0 apples. Obviously that one's not true because I didn't buy half a pumpkin, but somewhere in here is the actual combination of what's in the jar. So I'm going to give you more information here. There are 40 fruit in all, so I just need to come up with another equation that says the number of pumpkins plus the number of apples equals 40. And you can see that the solution is right there, 12.28. There are 12 pumpkins and 28 apples. Looks good to me. Next example says a jar has a mixture of quarters and nickels. There are 30 coins in all, totaling $5.70. There is enough information to write 2 equations. All right, so we have enough information here to write 2 equations. One of the equations is going to be to deal with how many coins are in this jar. And the other statement, the other equation, is going to be how much money is in the jar. So let's start with the number of coins. That one's easy. I'm going to say quarters are x and nickels are y. So the number of coins, quarters plus the number of nickels, adds up to 30. So that's a little better than the last one. I can zoom in a little bit. And then the second equation, I know that quarters are 25 cents, plus I know nickels are 5 cents. And when I add up the money that each of them make, my total is $5.70. And there we go. The intersection's right there. There's 21x and 9y. So there's 21 quarters and 9 nickels. Yep, that looks right to me. That's all for today. Thanks for watching.